さんこんにちは。Knowledge is the foundation for a just society. And if the citizens are not actively pursuing this knowledge, then justice cannot happen. I believe that we're in a situation where more than ever we need to have this knowledge because there are so many difficulties in this area. And especially about environment. Because if we want to have environmental justice, knowledge is really a condition. And environmental justice can sound like a very abstract or grand idea, but I'd like to use two simple examples and show tangible, simple ways that anybody can contribute to this knowledge and environmental justice. The first example I'll be taking is about oil spill or oil pollution. In 2010, the BP oil spill happened in the Gulf of Mexico. I was responsible for a team at MIT in Boston, and we were trying to develop a technology to clean up the BP oil spill. But that was really a terrible and really enormous environmental catastrophe. If you look at the scale of it, it would be just like if half of the coast of Japan would be covered with oil. That was the scale of the accident. And the technology we're developing at MIT were really extremely cool, but they were going to be very expensive, and it would take a lot of time to develop them. And so I left my dream job, and I moved to the Gulf of Mexico, where I lived for 2 years, to work with the local communities. And this is what we did. We didn't have much money, so we started with what was around us. And so we cut plastic bottles, and we put a simple $100 camera in them. And then we would inflate those party balloons and attach the camera under the balloons, or we would fly those kites. So we would attach the camera down the kites and take pictures from the sky. And so sometimes we would walk on a beach or get on a boat, and we would take literally hundreds or even oftentimes thousands of pictures in one session. And eventually we would stitch them, many small maps and more small maps, and eventually we would make those very large maps. And those maps the resolution is 100 times the average satellite imagery, but they cost much less. You can imagine, maybe not that much less than Mr. Yamada, professor. But what's really special about them is that we could make those maps whenever we wanted, and they were made by the residents. And yeah, so that was really important for the people so they can reclaim environmental justice. So BP oil spill was recognized as an environmental crime. BP was recognized as guilty of neglect. And what's special about this is that it is the victims of the environmental catastrophe that had to collect themselves the evidence to reclaim environmental justice. They had to be extremely creative and resourceful to reclaim environmental justice. And I think it's a very similar situation here in Tohoku. So it was a very fun activity as well to make. And beyond the community aspect, I kept being more interested in how we could actually clean up the oil spill. Making the image of it was a very useful thing, but how can we actually clean it up? So 700 of these boats were deployed, thousands of men worked on them, and many of them had health problems because of being exposed to toxics. But they collected only 3% of the oil on the surface because they didn't really pay attention to the natural patterns. That's my feeling. And so they were just eyeballing what the oil was and basically going where they could get it. But if you take the same amount of oil absorbent that they had pulling like this and you straighten it, you have a lot more surface area. But you cannot collect everything. But if you have multiple paths, maybe there's more chance to collect more material. But that's really hard to move such a large object against the wind, the waves, and the currents. So I thought, what about we use a technology that's thousands of years old, sailing, and could we sail up the wind and intercept the oil that is drifting down the wind? So that was a very simple idea. And so I didn't know if it was going to work, so I just took a small boat and tried to sail around. And what I found is that you're losing two things. First, you're losing the pulling power, and second, you're losing the capacity to steer. So I thought, maybe if I change the architecture of the boat and put the rudder at the front and the centerboard more at the back, I could control more. So I did that, and with a robot of 1 meter, I could control a payload of 4 meters. So that was a very encouraging first test. But then I thought, Okay, it's a bit like the cars. You have a you have a four-wheel drive. You have two wheels that can move at the front and maybe two at the back, and maybe you can increase control. And you can see if you have a boat that's a front rudder at the front, you have a very maneuverable boat, but it's going a little less fast. So I thought, well, okay, let's make one with two rudders. It didn't work so well. It was a very clumsy machine. But then I thought, okay, what if we make the whole boat become the rudder? If the whole boat can start to change shape, so if the whole boat becomes the rudder. And so that's the first shape-shifting sailing robots. And so what's happening there is that the same as you can control the shape of the sail, which you can adjust, you can trim the sail. Well, now you can do the same with this kind of boat. You can trim the hull. So you can really define the trajectory of the boat and how you go around. So you have a boat that's, well, not at this stage and at this scale, but we hope that we can make a almost kind of optimal boat in terms of how much we can maneuver, stability, absorption of the wave impact, and so on and so on. But what we were trying to do at the time was not this. We're trying to sail upwind and pull a lot of absorbent. So what's special is that you have two sails, and they can be potentially at two different angles of the wind. So you can never be stuck in irons. So if you're trying to pull something long and heavy, being able to have always wind in your sail is a huge advantage. And so the process by which we've been working is very much like an evolutionary process. There's lots of failure. Most of our robots will break and will fail, but we keep learning. Then we wanted to know, could this work at a larger scale? So we built this maybe $50 or $50 boat, just of plastic, boat from the local Home Depot, and that's an inflatable boat that we could pull. And then we mechanized it. So we put some motors inside of it and some computers. So that was in a factory in Rotterdam. So the team has been moving, and we've been collaborating with people around the world. But what it is really, this one is, it's a rocket with a sail. So you can bend the rocket, and it's got a lot of pulling power. And so now we're very excited because we start to make them in batches. So that's my bedroom last month. And sorry. So now anybody can buy them online, and most of our clients are different labs of hydrodynamics around the world who are interested in this technology. So we don't have to be pulling an oil sorbent. We could be pulling anything. So it could be made of modules. So if we want to study the impact of oil on fishes, we could have different research happening in different modules. And then we wanted to see, could we propel this into a modular way as well? So we prototype on land as well because it's faster and cheaper. So this machine is 3 meters, and it's very maneuverable. But what's my interest in this is that this machine is 3 meters, but we used exactly the same motor and parts on this machine that is 6 meters. So this machine is bigger than your car, but it uses less energy than your mobile phone when it rings. Because the only thing we need to control in this machine is the tilt of the front wheel. The rest is passive. So that's quite exciting to think that we could make a really large vehicle with very little energy consumption. So their next dream was, how can we bring this back to the water? And so that's what we did. But it's just 2 modules at this stage. But look at the position of the sail. So you have the jib, and it's changing side. And you have then the second sail that's going to change side. And you have the third sail where you see what I mean. And then what happens is that the boat will bend back to being straight and will dash forward. So the other cool thing about having a modular boat, and it happened to us, is that if it breaks, you have 2 of them. So we can always say that was made on purpose. And so we're really excited about this because we really need badly ocean-going robots, because the oceans have so many problems. I'm not going to start counting them. But because this type of machine have these properties, I think it's a very promising model. The technology itself is only not even half, I think, of the work that we have to do. The way we develop the technology is, to my point of view, is almost more important. So this technology is all open source. You can go online, download the documentation, make your own. So we invite anybody to use, modify, and distribute this technology for free. So if anybody in Tohoku wants to start a manufacture of this, we will actually help them. And the idea is that if technology is good for the environment, we believe that it should be available for everyone for free. And the ocean is big enough for everybody to help and have a business. So that's the network. So instead of being a proper company, we've been more kind of a network of inventors and hackers. And so it's been quite an adventure to manage a known company, and we're still learning how to do it. Okay, so now another theme that's closer to you, but actually it's also closer to me. I'm half Japanese. My father is from Niigata, and half of my family lives about 100 kilometers away from the Fukushima nuclear power plant. And so when it happened, I came in 2012 for the first time, and I wanted to know what was going on. So I borrowed a bicycle from a friend in Tokyo, and I cycled alone from Tokyo to Sendai. So it took me about 10 days because many roads, as you know, were broken at the time. And so that was a very instructive trip. I saw moonscape almost and see people walking like ghosts, and that was really hard. But I was amazed by the people I met on the way and how courageous they were and how much energy they were putting into reconstructing their life and the economy and their families. So I stopped every half an hour on the bicycle, and I would measure the radioactivity. And you can see I'm going along the coast because I'm looking for a place to launch my boats, because I'm dreaming, I'm cycling, and I'm thinking maybe my boat sometime can help understand radioactivity in the ocean. So that gives me energy to cycle. So I came last year, this time more organized. So we got a nice car. So this is my friends of Safecast. They make these Geiger counter. They are open source Geiger counters. They have a GPS, so you carry it around, and you go back home at night. You put your SD card, and you can contribute to a global map of almost real-time radioactivity. Anybody can actually help that. But what we did is that they were not very happy, but we broke their Geiger counter, took it apart, and tried to make it waterproof. And we tried to fit it into a boat, and that's why we developed it. It's an underwater Geiger counter. So we tested it, and it worked, but it's very, very unreliable because water is a very good radioactivity shield. And so that's why I'm here again this year. So I'm here because I want to make it work. And so that was the dream last year. We're thinking it would be so cool if we could have a Geiger counter under the boat and just keep measuring radioactivity, upload data online, everybody can see what's going on, it'd be awesome. But it's really hard. And so this is a French team of engineers from Areva, and they're just trying to do this. But the measurement they get is very unreliable. Just the same problem as we had. Water makes it hard. And so right now we have that's a simulation made of where the radioactive particle or dust could be transported into the ocean. That's a really great simulation, but it's not based on much measurements. So that's what we think radioactivity is, where we think it is, but we cannot really verify that unless we go there and measure it. So we have on one side now a great set of land data, which is extremely reliable. And on the other side, we have some models of simulation, but based on a very, very few measurements. And in the middle, you have some groups, here at Umilabo and some professors in university are making a few of these samples. So we have a huge deficit of data of what is the seabed radiation. And so what I observe as well in the experiments is that the sampler that they use is called an Ekman grab. It's a box that goes at the bottom of the ocean. It's got two jaws, and it will just grab the sand and then go up. The problem is that it grabs not only the surface sand or sediment, which is more contaminated, but it also grabs what's deeper, which is not contaminated. And so you have an average of the radiation of the last 5-10 years, but it doesn't tell you what's the level of radiation right now, and that's a problem. So I thought, okay, can we develop something very cheap? And so that's the prototype, built in half a day. Actually, I built 4 of them in half a day in my workshop. And what it does, instead of grabbing deeper, it just goes on the water surface, and you drag it. And what it does, it just carves or just gets a few millimeters of sand at the bottom of the sea. So this is 3 days ago. So 3 days ago, we were on a ship, and we sailed up to 1.5 kilometers from the Fukushima Daiichi. And we used this device, and we collected sediments. But what I really like about this video that we edited yesterday night is that you see us at the beginning, we're very nerdy, and this is our invention, and we're so happy about it. And then you see the old fisherman behind, being super bored and thinking, these guys don't know anything. And then he took the line from our hands, and he started using it, and he collected 5 times more sediments than we did. And he was so into it. We couldn't use our sensor anymore, so he wouldn't let us play with our machine. And so he was very happy. But what I really love about this is the idea that I'm not a fisherman. I can invent a cool machine, but he definitely is a lot better than me at using it. So we're so excited to come back here again and work with fishermen to improve this technology. So these are the samples we've collected, just like the image to make the map. It's the same. We have to collect those to make those maps. So these are the points we've collected, and these are the points we hope to be collecting in the next few days if weather allows. So this is where we are. We have a great set of data for the land, and I'm trying to see who is interested. If you're interested in this room, please come talk to me of mapping the sea, because that's so important. If we want to rebuild the fisheries, the industries, and have the resident coming back, we're going to need this information. So, yeah. So the ocean is the future of, in my mind, of everything, because that's where all life comes from. In the whole universe, where it started. And it's also the future of our food, seafood, energy, wave, solar, wind, communication. Most of the internet is happening underwater. Fiber optics. Security. Most of the warfare is happening through the sea. Transport. 90% of the world trade is transported by ship. This is major. And Japan is an island. So there's actually, that's your resource. That's our resource. So knowledge is the foundation for a just society. But right now, this knowledge is dividing many communities in Tohoku. The people who believe in the government and in TEPCO, and the people who don't. But it's because many people in the civil society are not involved in the process of creating that knowledge. And I feel that if we have tools like this one that cost maybe 500 yen to make, and that anybody could go behind a fishing cane and collect some samples, send by post, that would be so cheap to make. And then the people will feel that they're part of creating this information, and they will trust this information. So then they will be able to come back because they made this information themselves. They're part of the process. And so I think that's open source is going to be a very important part of this transparency and being able to bring back peace and cohesion in our communities. So that's the beauty of open hardware. It brings the academia, the government, residents, and even industrial, because I'd be happy to manufacture some of these and sell them. They're cheaper, but sell them. And so yeah, so I hope that open technologies can empower Tohoku communities and for the environment. Thank you very much.